Hello, hi, I'm Punita here from Huawei Global Training Center. Today we're going to discuss about the content eNodeB radio data part 13. So let's look into cyclic prefix concept. So basically this is for line of sight path. So cyclic prefix is calculated based on the multipath echo arriving within the cyclic prefix, multipath echo arriving after the cyclic prefix. So basically it's actually to avoid the delayed signals. So why we have cyclic prefix? Because we need the gut period. Okay, that is one thing. And also we need to measure based on the radius, the coverage radius. So how many symbols will be configured? Example, if normal CP, we will have 7 symbols. And if extended CP, it will have 6 symbols. It's based on the coverage radius. So that is to avoid the path loss, at the same time to avoid the delayed signals as well. So it depends on the radius. So if less than 15 kilometer radius, you can use more symbols to be transmitted. If the radius is extended more than 15 kilometers, then probably you need to reduce the number of signal to avoid the loss of path and also to have less delayed signal. So this is the main reason why we have a cyclic prefix configuration, or this function is introduced. So where do you insert the cyclic prefix? So basically it will be in the frame structure. So we will have an cyclic prefix extended in the frequency. So this is the symbol period, bit period. So in between we will have the cyclic prefix. So on another words, when you talk about cyclic prefix, we also need to configure this in the cell level. So cyclic prefix, the purpose of this cyclic prefix is to combat the inter-symbol interference. We don't want to have same symbol repeated. So it is actually a guard time made up of a replica of the time domain of OFDM waveform, because we have 7 symbols and 6 symbols. So the basic OFDM symbols will be creating the guard period. So this one is actually the guard period. So this one is GP. So the guard period. So that is the cyclic prefix communication. So it is used to in the case of delay. Okay, when you have a delay between the signals which is very low. So we will try to adjust with the guard period. So the CP size, the cyclic prefix size, LG can use 2 types, normal CP and extended CP. So this is 7 symbols and extended CP is 6 symbols. So NB-IoT can use only normal CP, which is 7 symbols. So we know the radio frame is 10 millisecond. So this is basically when we actually extend, we will have the guard period. You see, when you have 7 symbols, the guard period is shorter. Time slot is 0.5 millisecond. But when you have extended CP, it's a little bit larger. The delayed signal is a little bit larger. So that is actually the difference. So how you select a cyclic prefix? Cells with larger coverage are expected to have longer delay spread. So in this case, an extended CP needs to be configured. So if you have a longer delay spread, you have to use extended CP. In other cases, normal CP shall be configured. So what is the rules for the cyclic prefix selection? If the cell radius less than 15 km, you use a normal CP. Otherwise, use an extended CP. So this is the cyclic prefix configuration. Under the downlink cyclic prefix length, you need to select normal CP or extended CP. So let's look into the example when we view the add cell. So you will see that there is a configuration of a cyclic prefix. So we have normal CP and extended CP. So if it's less than 15 km, we will use normal CP. So Q&A session, Cells with large coverage are expected to have longer delay spread. Yes or no? Yes, this statement is true. So the summary of this section is that we have discussed about what is cyclic prefix function, what is CP insertion, what is CP size, what is the cyclic prefix selection, and what is the cyclic prefix configuration. Hope you enjoy the session. Thank you. That's all from me. Bye.